The OSI model, Open Systems Interconnection, has 7 layers, numbered 1 through 7 from the bottom up. You've probably seen this before, but we're going to look at it with fresh eyes because in an automation context, these layers tell you exactly where your tools and protocols live, and they give you a structured troubleshooting checklist when something breaks. Check out the stack on screen and notice 2 columns, the layer name and the protocol data unit, or PDU, which is simply what we call a chunk of data at that particular layer. Start at the bottom. Layer 1, physical, this is raw bits, signals on a copper wire, pulses on a fiber optic strand, or radio waves in wireless. Layer 2, data link, bits get organized into frames, and this is where MAC addresses, VLAN tags, and 802.1q trunking live. Layer 3, network frames become packets, and IP addressing plus routing decisions happen here. Routers operate at layer 3. Layer 4, transport packets are tracked inside segments, and this is TCP versus UDP territory. Reliability, port numbers, and connection state. Then layers 5 through 7 all deal with data generically. Layer 5, session, handles the establishment and teardown of application layer sessions. Layer 6, presentation, handles encoding, compression, and encryption. Layer 7, application, is where the protocols you actually interact with live: HTTP, DNS, SMTP, SNMP, SSH, and every REST API. Here's why this layered model is critical for automation specifically. Every API call your Python script makes operates at layer 7. netconf, the network configuration protocol, uses SSH as its transport, which means it bridges layer 4 and layer 7. When you're troubleshooting why your Python script can't reach a device, you start at layer 1. Is the cable connected and the interface up? Layer 3, can you ping the device's IP address? Layer 4, can you connect to TCP port 22 for SSH? Layer 7 is the API responding on port 443 or 830. The OSI model is your methodical troubleshooting checklist. Know each layer's PDU name cold, and know which well-known protocols live at which layer. Because the exam will hand you a scenario, the TCP IP model is what actually runs on your network day to day. It has 4 layers instead of 7, but it maps cleanly and directly onto the OSI model. Understanding that mapping is a common exam question. So let's walk through it carefully. Look at the side-by-side diagram. TCP/IP's network access layer combines OSI layers 1 and 2. That's your Ethernet frames, your MAC addresses, your physical cables, and wireless signals. TCP/IP's internet layer maps exactly to OSI layer 3. IP packets, IPv4 and IPv6 addresses, and routing decisions. Transport is the same as OSI layer 4. TCP for reliable ordered delivery, UDP for low overhead fast delivery. And TCP/IP's application layer absorbs OSI layers 5, 6, and 7. That's where HTTP, DNS, SSH, SMTP, and SNMP, and every REST API call lives. Now, the concept that makes all of this click together, encapsulation. Think of it like a set of nesting envelopes. Your application data, let's say the body of an HTTP request, goes into the outermost application envelope. The transport layer wraps that in a TCP or UDP header that adds port numbers and sequencing. The internet layer wraps that packet in an IP header containing source and destination IP addresses. The network access layer puts the whole thing inside an Ethernet frame with MAC addresses. Each layer only reads and processes its own envelope and hands the rest down or up the stack. On the receiving end, we unwrap and reverse. That's decapsulation. Each layer peels off its own header and hands the payload upward. For automation, the key takeaway at the bottom of this slide: REST APIs live at layer 7, application over TCP port 443 for HTTPS. But netconf, the structured configuration protocol, tunnels over SSH. meaning it operates at layer 4 using a TCP connection on port 830. That's not a standard HTTP connection, it's an SSH session on a non-standard port. And the exam tests exactly this kind of cross-layer awareness. Lock in that mapping, netcon fuses SSH, SSTCP, the port is 830. All right, let's check in before we move on. 3 questions. Take a genuine moment to think through each one before reading my answer. The retrieval practice is worth it. It's how facts stick. First question, which OSI layer handles IP addressing and routing? Take 5 seconds. The answer is layer 3, the network layer. IP addresses, both IPv4 and IPv6, live at layer 3, and routers make their forwarding decisions by examining the layer 3 packet header. If you said layer 2 or layer 4, that's a really common mix-up. Layer 2 uses MAC addresses and layer 4 uses port numbers. Layer 3 is IP addresses and routing. Plant that flag firmly. Second question, what is the PDU name at the data link layer OSI layer 2? That's a frame. Bits arrive at layer 1 and get organized into structured frames at layer 2. Each frame has a destination MAC address, a source MAC address, the payload, and a frame check sequence for error detection. VLANs and 802.1Q tags also live inside the layer 2 frame. Third question, name 2 reasons automation is preferred over manual CLI configuration. There are several correct answers, but the strongest 2 are consistency. Every device receives the exact same configuration with 0 manual entry variation. And scalability. You can push changes to hundreds of devices in the time it takes to manually configure 5. Speed and auditability round out the list. If you answered both correctly, you've nailed the business case for automation.